In this video, we're going to go through examples 11.1 to 11.12 in your book. If you'd like to follow along, open the Better Chapter 11 Classwork.xlsx workbook from My Courses and click on the Modeling Car Pay Worksheet tab. There are actually 12 different examples of modeling, and if you'd like to go through them, I posted a Chapter 11 classwork file in My Courses, but it tends to be very repetitive, and really they talk about models, but they don't talk about modeling. So let's talk about this particular problem. Let's say you're going car shopping, and you're looking at a $25,000 car. You're going to put down $6,000. You have an annual rate of 3.75%, and you'd like to finance that car over 5 years. Well, first of all, let's just put in a formula to calculate the monthly payment, and then let's see how we can model this a little bit better. So I'm going to click in cell B2, and I'm going to click Formulas, and then Financial, and I'm going to scroll down until I see PMT. Calculates the payment on a loan based on constant payments and a constant interest rate. So in the rate, I'm going to type 3.75%. Don't forget that percent key, that's very important. Or 0.0375 would work, but I have to /12 because it's a monthly payment. In N per, I'm going to type 5 years, and then I'm going to multiply that by 12 for 60 total payments. And then in my present value, I'm going to type negative, and then 25,000 minus 6,000 is 19,000. And I have a monthly payment of $347.77 a month, which seems very reasonable. Now, if I was trying to do a what-if analysis, it would be very difficult to alter this formula. So if somebody said to me, "Oh, Debbie, let's change the down payment from $6,000 to $5,000, I'd have to think, okay, 25,000 minus 5,000, that means that the payment is now 20,000, so I'd have to edit the formula within the formula. If somebody else said, let's see what it is with 6 years instead of 5 years, I'd have to double click the cell, go in and edit the formula, so it makes it very difficult to track what you're doing. So instead, what I'm going to do is I'm going to put in an input area, and I'm going to put an output area. In my input area are all of the different variables. So really the only variables in this problem, are the cost of the car, the down payment, the annual rate, and the number of years. And from that, we can calculate both the monthly payment and the total interest paid. So first, let's calculate the amount financed. It's not really necessary, but it'll make the payment and the total interest paid a little bit easier to calculate. So I'm going to click in cell B10, and I'm going to type equals, and I take the cost of the car, cell B5, and then subtract the down payment, cell B6. Notice how there are no numbers in this formula in my output area. I'm depending upon cell references only. Now I'm going to type in my monthly payment. So I'm going to make sure that I'm in cell B11, and I'm going to click Formulas, Financial, and once again PMT. But now this time in the rate, I'm going to click on the 3.75%, so I'm going to click on cell B7 and then /12. In the N per, I'm going to click on the 5 years, so I'm going to click on B8 and then multiply that *12. So notice I get 60, and I get the same rate that I got before. And then in PV, I'm going to type a negative sign. That negative sign is necessary because otherwise the payment comes out negative, because if you borrow $19,000, you'd have to make payments of $350 a month. So negative, and I'm going to click on the amount financed, cell B10, and notice I still get my $347.77 a month. So I'm going to click OK. Now I'll show you the benefits of the modeling once we calculate the total interest paid. The total interest paid is going to be the total of the payments minus the amount financed. So in this case, you're borrowing $19,000 and you're returning 60 payments of $347.77 each. So the difference between what you're paying back and what you're borrowing is the total interest. So I'm going to click in cell B12. I'm going to type equals. I'm going to click on cell B11. I'm going to multiply that by the number of years, cell B8. I'm going to multiply that by 12. So that is 60 payments of $347.77 a month. And then I subtract out the amount financed. So I'm going to click on cell B10 minus B10. And I hit enter. And on this loan, when you get those pound signs, it just means that the column is not wide enough to display your number. So I'll make column B a little wider. And I have total interest paid of $1,866.47. So I want you to notice that in each of my formulas, down here in the output area, the only number that you're going to see is 12 for the number of months in a year. So the amount financed is dependent upon two cells in the monthly payment. We can see B7 for the interest rate, B8 for the number of years, and B10 for the amount financed. The only number is 12. And then once again, in the total interest paid, totally dependent on cell references, the only number is 12 for the number of months in a year. So I hit enter, and now because of my modeling, I know that I can change any number in the input area, and I know that my output area is correct. I don't have to touch any of the formulas. So if somebody now comes to me and says, okay, Debbie, I want you to do a $5,000 down payment instead of a $6,000, I can just type 5,000. Let's see what it is going 6 years instead of 5 years. Notice all my numbers change. Everything's correct, so we know what's going on with our model.